Hey there. Ever wonder about the invisible magic that's happening inside all your electronics? Well, today we're going to pull back the curtain on one of its biggest secrets.
Why does a dimmer switch actually dim? Or how come one phone charger juices up your battery way faster than another one? The answer, it turns out, gets to the very heart of how pretty much all of our gadgets work.
And believe it or not, the answer is so elegant. It all comes down to this single, fundamental rule that was figured out almost 200 years ago. It's a rule that governs the flow of electricity in everything, from a simple little light bulb to the most powerful computer.
So let's get right into it. What exactly is this law, and why is it such a big deal? This is the foundation, folks, the absolute ABCs of electronics.
Okay, that sounds a little academic, doesn't it? Directly proportional? All it really means is there is a super predictable relationship between the electrical push you use and the flow you get as a result. Think of it as a simple cause and effect. To make this crystal clear, let's just picture it. You've got voltage, measured in volts. That's the force, the push, that gets electricity moving in the first place. Then you have current, measured in amperes, which is the actual flow of that electricity. And finally, there's resistance, measured in ohms, and that's the opposition. It's what slows that flow down, the limit. So, the push, the flow, and the limit.
And this brilliant little equation ties them all together. Voltage equals current multiplied by resistance. With this one simple formula, we can unlock and predict how almost any basic circuit is going to behave. It is the key that fits every single lock.
Theory is great and all, but seeing is believing, right? Let's put this law to the test. We'll use a simple, practical example to see exactly how these three components dance together.
Okay, so let's just build a quick circuit in our minds. We have a power source, that's our battery, giving us the push, and we have a resistor, which is giving us the limit. The only thing we don't know yet is the flow, the current.
So our starting point is the push. We've got 6 volts of electrical pressure coming from our battery.
And working against that push is our limit, 3 ohms of resistance. This could be, a small light bulb or some other component in the circuit. Now, we just take our main equation, V equals I times R, and we just rearrange it a little to solve for what we need. To find the current, which we call I, we simply divide the voltage by the resistance. So that's going to be 6 volts divided by 3 ohms. And there it is. The answer is 2 amps. With a 6-volt push and a 3-ohm limit, we get a completely predictable flow of 2 amps of current. It really is that simple.
Okay, now for the fun part. Let's really put Ohm's law to the test. What happens if we double the push to 12 volts, but we keep that same resistor?
The setup is exactly the same. We take our new, bigger push, that's 12 volts, and we divide it by our unchanged limit of 3 ohms. And look at that! The current is now 4 amps. We doubled the voltage, and the current doubled in perfect response. That is what directly proportional means in the real world. It's a perfect relationship. And this chart just lays it all out so clearly. More push results in more flow, as long as the limit, the resistance, stays the same. It's a perfect straight-line relationship. So we've done the math, but why should you actually care? Well, because this isn't just some formula in a textbook. It is running the world all around you, right at this very moment. Remember that fast phone charger and the dimmer switch we mentioned at the start? Ohm's law is exactly how that charger delivers the right amount of current without totally frying your battery. And the dimmer switch, it just works by changing the resistance, which Ohm's law tells us will change the current, and boom, the brightness changes. It is everywhere.
No exaggeration. Without this simple law, we just wouldn't have modern electronics. It is the bedrock, the absolute fundamental starting point for every single circuit ever designed.
So if you're going to remember just one thing from all of this, let's make it this. We're going to boil it all down to its absolute essential core.
First, voltage is the push. It's the force that makes everything happen.
Second, resistance is the limit. It's the gatekeeper that controls how much flow you get. And finally, V equals I times R. The push equals the flow times the limit. If you can master this one simple idea, you've pretty much learned to speak the fundamental language of electricity.
So you now have a really powerful tool for understanding the electronic world. But Ohm's law has friends, So where should we go next? Should we tackle Kirchhoff's laws of circuits, or maybe dive into Joule's law of heating? Let us know what piece of the puzzle you want to unlock next time.